Okay, now we're recording. You have your mathematical types on the right, and then you have, I think they're called program types, but I'll correct myself. That's fine. On the left here. And we say that mathematical or program types are modeled based off of mathematical types. So the big, easy way to think this is integers. So in programming languages, you can have an integer which stores either positive or negative integer values, say 13 or negative 13. And this is obviously modeled based off of mathematical integers, which are any whole positive number. We say it's modeled off of mathematical integers because you can't store every single type of integer. It's on the next upcoming slides, but I think the maximum value you can store in an integer is like 2,147,000,000 something. And that's just because the way that integers are stored in Java memory is such that the maximum value you can store is up to that 2 billion. If you don't believe me, you can go into Eclipse right now and try to store the value of an integer of like 1,000 different numbers and then try to print it, and Java will yell at you because it's too large. Okay, so this is a Boolean variable. It's called B, so it has the name B, it has the type Boolean, and it has the value true, whose value is true, i.e. B equals true, or more simply, just B. This is a char variable C, so it has the name C, it has the type character, and it has the value Y. So on and so forth. We have an integer variable whose name is I, type is integer, value is 13, and then double is 3.14. And then the string variable whose value is go, i.e. S equals go, or S equals the character string GO. Which is another way of representing strings is through this string of characters. Because if you remember last week, we talked about how strings are simply just strings of characters. Okay, is that good so far? Thumbs up, thumbs down, thumbs a little bit to the side. Okay. So a type is the name of the set of all possible values that a variable might have. So for example, a variable of type string might have values like foo, hello world. If you're a bunch of monkeys on a typewriter in a rocket ship, it could be the entire works of Hamlet. That would be part of the set of strings that a string value might have. A variable of type int might have values like -1, 18. A variable of type double might have values like 3.1416, 10.0, etc. This is not an infinite set in the case of integers, doubles, or strings, because again, they max out at some arbitrary value. Not arbitrary, but some maximum value in Java. And there are ways to get around that, some of which we talk about very soon. So program variable has a particular value at any one time during program execution, and that value generally may change at other times, but the mathematical variable stands for an arbitrary but fixed variable. So if we have a program variable, say we have that integer I, throughout the course of the program, the I might take on different values in the set of integers. So let's say you have -3, -2, -1, 0, 1, 2, 3, 4, 7, 4. Throughout the program, the integer I might change its value from -3 or 1 or 3. But -3 is always going to be -3. 1 is always going to be 1. These mathematical constants, these mathematical literals will never change. So mathematical variable is an arbitrary but fixed variable value. Program variable has a particular value at any one time during program execution, but can change. So you can look at any line in your program, or you can stop the program at any time, look at all the variables, and define what the program variables are equal to. And that's something that you will do often in something called tracing tables, which we'll get into. Okay, so a program type has a corresponding mathematical type that models it. So integer into the set of integers, and I think there's a nice table up here soon. Okay, when reasoning about a program variable of a given program type, treat its value at any given time as if it were a mathematical variable of the corresponding mathematical type. So if at some point during our program, our integer I that we have here is based on or is corresponding to the mathematical type or the mathematical value of 1, then when we use I, we treat it like a 1. It is holding the spot for the mathematical type 1. And here is that table that I mentioned. So here are all of or some of the program types that you're going to be using most often and what their mathematical types are. So you have a string, which is modeled by a string of characters, any character string really that you can think of. You have a Boolean, which is modeled by a mathematical Boolean, which I'll spoil it for you, can either be true or false. A char, as it's called, which is modeled by a character. An int, which is modeled by integers. There's that big number that I said before. I think it actually might be larger than I initially said. Yeah, that is 2 trillion, I think. 2 trillion, like 147 billion. So you can store big integers, but you can't store big integers. Speaking of which, there is something called big integer, which we'll get into later, that allows you to store bigger integers, believe it or not. And then double, which stores this mathematical type called real, which we'll talk about later, but it is about 10 to the power of plus or minus 308. So up to 15 significant digits. So if you wanted to store 13.00, 13 more zeros, 1, you would not be able to because Java caps it out. If you're having trouble, a good, I guess, real world example, or how I like to think about it, if I can't wrap my head around it, is if you've ever played Pokemon, you have the Pokemon Ditto, who's like a little guy. He is like a program type, and he's modeled based on the mathematical type of the set of all Pokemon. So at any point during the battle, Ditto can be any one type of Pokemon. It could be a Charizard, it could be a Pikachu, it could be another Ditto for all you care. Ditto is kind of like modeling a mathematical type. That's a real world example if you want to think about that. So if you're on a midterm, actually don't write down that program types are like Dittos because you might get points off. But that's a good way to think about it. So string is a built-in to Java. So Boolean, char, int, and double are among the 8 what we call primitive and also built-in types of Java. So these are program types modeled after mathematical types that we have built into Java that we don't need to make or import for ourselves. We can compare these to the custom types that we're going to be using later of the OSU CSE components, which also are modeled based off of mathematical types, but are not specifically built into Java. Any questions so far? Okay, all of these mathematical types are built into mathematics. So everybody knows, or mathematicians have a very formal way that you define an integer or a formal way that you define a real number. Okay, and how we will differentiate between them in the slides is that program code is shown in a blue fixed width font with keywords in bold. Keywords are essentially words that Java will not let you call a variable or things that you should not name your variable. So you can't name a Boolean Boolean. You can't say Boolean Boolean equals true. Java will get angry at you. Contrast this to mathematical variables, which will always be in green fixed width, italic font with keywords in bold. So anytime you see a blue text, it's going to be a program variable or something that we reason about in Java, and it's modeling these green text mathematical types. So when you declare a program variable, you provide both a name and a location to store its value, and that indicates its program type. So when we call int j, we are telling Java, hello, go to my little storage facility deep within the computer guts and create a box called j. It's going to store program type integer, which means that it can store anything between 2 trillion, 147 billion. I don't know what's going to be in it yet, but make that box and be prepared for variables to be incoming. Where did my chunk go? Oh. So that's how you declare a variable. The standard Java convention for naming variables is to use camel case. So I'm going to erase all of this. Is that okay? Scream now if no. Okay. So there are many different ways that people name variables. I don't particularly care which one you use, as long as the variables are named correctly. I had a friend who took this class and named every single one of her variables just A, B, C, D. Do not do that. Variables should be representative of either the value that you're storing, or no, just the value that you're storing. So if you're storing the value for pi, your variable name should be pi. If you're storing a user input, the string name should be user input. It should not just be A, B, C, D, E, F. But if you have a variable name which is more than one word, there's different ways to do it, but camel case is probably the most popular, which is you start the first word with a lowercase letter, and then every single word after that has an uppercase letter. So let's say we're doing professor name. You start with the first word as a lowercase, and then every subsequent word is an uppercase. Professor name and other words. It's called camel case because the uppercase letters look like camel humps, I think. It's the idea. Some people use underscores. That's valid too. The reason that you do this is because try writing your variable names in all lowercase. It's kind of hard to differentiate between the words and such like that. So only capitalize the first letter of each following word, e.g. my lucky number. The L and the N are capitalized. Okay, so we talked about how to declare a variable, which is int j. You provided it with the type and the name, but no value. So we say that at that point, the value is undefined. It has the capacity to store any integer, any mathematical integer, but it is not yet having a value because we have not given it one. To initialize a variable, different keyword there, you have declaring a variable and then initializing a variable. You assign it a value. So remember, the program type determines the mathematical type, which in turn determines all the possible values that the variable can have. So you cannot say int j equals like the string hello world, because hello world is not in the set of possible values that an integer can have. Assigning or initializing variables in Java uses the equal sign. It's not meant as equality. It is meant as sort of declaration or assignment. So we're saying this integer j, so integer j of type integer should be storing the value 13. So somewhere down here, there's the mathematical type 13, which is in the set of integers. And we're saying at this current time, I should be 13. Or, sorry, j should be 13. My bad. Okay. In variable j, whose value you see in green is 13. So the mathematical fact that we are modeling with this variable is that j is equal to 13. Okay. Tracing tables. I will tell you this right now. Both of the midterms last semester had a tracing table. The final had a tracing table. Any of the study materials that you receive from the test bank will have a tracing table on it. I would be so incredibly surprised if both the midterms and the finals for this class this semester did not have a tracing table on it. Bucci loves them, and he makes the tests. So there's homework assignments where you do tracing tables. There's labs where you do tracing tables. Practice them, practice them, practice them. So they're important. What are they? A tracing table is basically a way to declare or a way to look at the code at certain points during your program and reason about what the mathematical type of certain variables are and what the program types of certain variables are. So mathematical facts, or things that we are modeling, are on the right here in this state column. And then on the left, we have actual Java code. So what will happen is this is the world as we know it before this line is written, and each row indicates just passing of time. So before we initialize j equal to 13 in our code, there is no j equals 13 in the mathematical world because there is no variable j yet. When we call int j equals 13, then afterwards in our world here, or in the state of the program at the time, the mathematical fact j is equal to 13 is true. Now, if we had another row right down here, which we created a new variable, let's say, let's use like string hello equals 5. Then we would have another row below that, and the state of the program at that time would have a hello in green, which would be equal to a string hi. Good so far. Thumbs up. Awesome. Okay. Every other row in the left column contains some program statements, so actual Java code that could be executed. And every other row in the right column contains some mathematical sentences or facts. So facts about the program as it currently stands. Because remember, variables can change throughout the program. So the fact that x is equal to 1.414 right now and j is equal to 13 at this particular time does not mean that it will be so later on in the program. Okay, the equal sign in code means assignment of a value to a program variable, not equality, like we talked about, or like in mathematics. However, on the right side, in mathematics, the equal sign means equality of two values. So here, on the left side, we're saying, hey, set 13 equal to j. Here on the right side, we are saying j is equal to 13. Slight difference there. Any questions, comments, concerns? Cool. And as I said, there is no mathematical variable j in this state because the program j hasn't been declared yet. So there's no need to talk about it. As far as the program knows, if you just cover like the bottom of your screen, that's the world in which we live in. And then slowly but surely, you reveal each line. And only then do you add j to the state column. Okay. And then because we've declared j, we write it down as a mathematical fact that j is equal to 13. Okay, literals. We talked about this a little bit last week, but as a reminder, a data value or a mathematical value appearing literally in a program is called a literal. So foo.txt is a string literal. False is what we call a Boolean literal. W is called a char literal, so on and so forth. Anytime you see literal mathematical values, mathematical in the sense of they represent a mathematical type, we call that a literal. So string literal is written between characters. Written between double quote marks. Boolean must be either true or false. A character is just a single character written between single quotation marks. So strings use double quotation marks, characters use single quotation marks. Integer, normally written as a decimal constant, and then you have double, which it just means it has a decimal point. And so here are some examples of string literals. You'll notice that some of them look a little bit wonky, so let's talk about those special cases. Essentially, how Java treats strings is it says, hey, anytime that I see two sets of parentheses, anything between them will be considered a string, but that causes problems for, let's say you just wanted a string with a quotation mark in it. Or you wanted a string with some other character that is important. You use what's called an escape character. So say backslash here. But a backslash will let Java know, hey, the next character that you're going to see, don't treat it like its actual character, just treat it like a literal. So that's why if you wanted to write this string at OSU, which in program code would look like this, at OSU, you use those two escape characters in order to actually include the quotation marks within the string. Okay, Booleans are just true or false. Nothing about that is that interesting. Again, if you wanted to have a single quotation mark as a char variable, you use that escape character again. /t is a special one, which just means tab. So if you printed out /t, it would just tab over. That's for like formatting things if you want. This is does anybody know what this is? Does anybody want to take a guess why this character has 5 characters? It's okay if you don't. It's a Unicode character. So we'll go down here. A Unicode character is how you sort of print out things that don't normally have keys on a keyboard or things that you can't just type. So this is the Unicode character for the Greek letter pi. Fun fact. So if you ever wanted to print out pi, you could use that Unicode character. Integers, you can store integers in octal if you wanted to. I don't think we ever do this, and I don't know why you would want to, but you can do it. Java lets you do it. So that's fun. And then you can also have hexadecimal integers. We will never deal with these, so you don't have to worry about them if you don't want to. But it's a thing that you can do. The world is your oyster. Don't make me stop you. But if you do write all of your integers in hexadecimal, I assume the graders will not be too happy. Doubles, you can have scientific notation. Again, don't write your programs in scientific notation. Just keep it simple. And then this, which I think is Avogadro's number. Can somebody? Okay, cool. Yeah, 6.022. I don't know. I failed chemistry in high school. Okay, constants. A variable whose values is initialized. Excuse me. A variable whose value is initialized and never change is called a constant. So these are things that, again, aren't going to change. So if you have an integer my lucky number, which is 13, and that's never going to change throughout the program, or if you have, oh, there it is, Avogadro's number, which is never going to change unless they come up with some scientific breakthrough, it's called a constant, and we have a special keyword for that, which is final. And that's you telling Java, hey, do not let anybody change this value because it's important, and it's called a constant. So that's what tells Java that it's a constant. What tells people who might be reading your code, who might just skip over the keyword final, is you write it in all caps with undercases. So you yell at anybody writing your code or reading your program like, hey, 13 is my lucky number. 6.022 e to the 23 is Avogadro's number. And usually they're written at usually they're put at the top of a program. So anytime you declare a constant, it's good to declare it at the top of the program so that you can use it throughout. Okay. And that's everything on variables, types, and values. Are there any questions? Cool. Next, we are moving on to operators, expressions, statements, and control flow. Some of this stuff might be review. Some of this stuff is very important. A lot of this stuff gets covered on the first midterm. So, operators is a symbol or a combination of symbols that is used with variables or values to simplify how you write certain program expressions. Expressions are one of the two things we'll talk about, expressions and statements, and the difference between the two is very important. And we'll get into that. Usually operators are designed to mimic mathematical notation, but do not be fooled into confusing programming and mathematics. We are better than the math majors, so don't confuse them. And here are the most common operators for the different program types. And so we're just going to go through all of them. String, we have a plus sign. I think we talked about, I got to stop doing that. We talked about last week that you can concatenate two different strings. So if you have the string hello with a space, add world, what will the resulting string be? Hello world. Nice. You'll notice that this bottom row, which seems to be a bunch of equality things or equality statements or equality operators, third time's a charm, does not have an equals sign. And that is because it is a huge no-no to compare strings using equals. So if you have a string hello, then you have another string, hello. This would not be a good way to compare two strings. Equals, by the way, is the comparator operator. So if you want to test for equality between two program types, you would use equals. So let's say in your memory, you had I, 7, and J, 8. I equals J would return true if they're equal and false if they are not. So in this case, it would return what? False. But if I switched J to 7, it would return true. So that's how you would do it for integers and you can usually also do it for, yeah, characters and Booleans. However, double and string is a huge no-no. So if you have like 3.0 and that's string and 3.0, it's not good practice to use equals equals. So how do you compare two strings or two doubles? There is another method which we'll get into called dot equals, which you can use, but that's nothing to worry about right now. And the reason that this happens, I'll spoil it, is because strings are not what we call primitive types, where the actual value is stored directly where you declare it. Strings are what are known as reference types. So if you have a string S, instead of actually storing the value of the string, you store a reference to somewhere else where it's stored. So when you use the equals equals, it's comparing just the value at the actual storage location. And since the value at the actual storage location is not a value, it's a pointer to another value, Java gets very angry if you try to do it. Now, if you try to disprove this and you use equals equals and it works correctly, technically, sometimes equals equals will work with strings, but it is still incredibly bad practice. It's like doing something stupid and not getting caught. Technically, you got away with it like cheating, but it was not good. So don't do it. Same with doubles as well. Okay, so that's string taken care of. You can concatenate two strings. Awesome. Boolean, you have this exclamation point. This, if you're reading it as English, just means not. So if you have a Boolean, let's say J, reuse this variable. It's not an integer anymore, it's a Boolean that equals true. If I say not J, what I'm essentially saying is false. This is the OR operator. So you read this as OR, and it's a way to reason about two different Booleans. So if you have, again, integer is now a Boolean as well. If you have true, and then J is also true, what you could say is you could have a third Boolean, let's say. Boolean, I think it's just bool, I forget which one. Boolean K equals I or J. And now K will be true if I or J is true. So at the current state, is K going to be true or false? And who can tell me why? Because both of them are true. All right, now let's say J is false. Is the value of K going to be true or false? Why? A little bit more interesting. Because even though K is the one of them is true. Yeah, even though J is false, I is still true. So the or statement holds. Now, probably see where I'm going with this. What's the value of K going to be now? I guess both of them are false. Cool. So that is or. Its brother is the and statement. And I'm just gonna, I can't really draw an ampersand. It's like a fatal flaw of mine. So I'm just gonna write and. J will be true if both I and J are true. So in this case, false. And the only way that it would be true is if both of these are true. Does that make sense? Cool. Java does something cool called short circuit evaluation. And I will explain with an example. Let's say you had a Boolean called like is weekend or is weekday. Yeah. Which can be either true or false. And then you have another Boolean called is 8 a.m. So is 8 a.m. And you're trying to write a program that determines whether or not you want to come to class today. So if you have an and statement, so let's say you're going to class if it is a weekday and it is 8 a.m. So Boolean going to class equals is weekday and is 8 a.m. You're only going to go to class if it is a weekday and if it is 8 a.m. If Java gets to this part of the code and it is not a weekday, so it's either Saturday or Sunday, or I guess Monday too, but bear with me. Java won't even check this second part of the statement because it doesn't need to. It already knows that this is going to be false because at least one of the two Booleans is false. So it won't even check if it's 8 a.m. Now, if it's true, then that's when we go to the second one and we check if that's true as well, which will be the final value. And that's what's called short circuit evaluation, because if the first value is false, there's no need to check the second value. So we short circuit, and Java saves like a little bit of runtime. So that's or and. Good so far. Cool. So we talked about equals equals. We have two Booleans. That second one with the exclamation point and the equal sign is not equals, and it's just the opposite of equals. So if two things are not equal to each other, it will return true. And if two things are equal to each other, it will return false. Okay, characters. We really only have comparison operators. We have less than, greater than, less than or equal to, greater than or equal to, equals equals, and then not equals. Equals equals and not equals work essentially the same as with Booleans. And then the less than or equal to operators. I think there's some master list where characters have an order, and less than or equal to work essentially the same way as they do in math. So if you have a character, let's say A, and a character B, I believe A will be less than B. Or if you use the statement A less than B, it will return a Boolean if that is true. And it'll return true if that is true, or return false if that's false. We really don't get into comparing characters, and it's really not that useful. Okay. Plus plus and minus minus are a way to be lazy as a computer programmer. So pay attention, because I know people love to be lazy. Essentially, if you have an integer and you want to increment it by 1, you can use plus plus. So normally, if you have an integer, let's say integer I equal 1, and you want to add to it, you could theoretically say I equal to I plus 1, which would increment the program variable by 1, or you could do I plus plus, which does essentially the same thing, adds 1 to the program variable I. You could do plus plus I. I don't know why I said that. Do not do this. People who use plus plus I are weird. Don't do that. It has to do with when it increments I, but it always just causes problems. Similarly, if we have plus plus, what do you guys think minus minus does? Anyone want to take a stab? Subtract what? Cool. Yeah. So if we have int I, which we've just called I plus plus and I plus 1, so let's say it's 3 now. I minus minus will subtract from it. You can add and subtract integers. I'm not going to go into that. That's just adding and subtracting. You can multiply, divide, and then this third one, modulo. These ones actually are pretty interesting. Java, when working with dividing integers, will always round down. So when you're thinking about fractions, or when you're dividing and there is a fraction, Java will always round down. So if you have 8 divided by 3, that is like 2.67 or whatever. So Java will do the math, and then it will say, hey, this is a double. I can't store this. I'm just an integer. And what it'll do is it will just cut off the rest. Like that. So if you're ever using integers in Java and you're using division, it will truncate down. Modulo, on the other hand, returns the remainder of an operation. So if you have 2 integers and you call modulo on it, it will do the division. So this is 2 remainder 2. It will say, I don't care about the actual answer, just give me the remainder. A big benefit of this is testing whether a number is even or odd, because if you have an integer and you call modulo 2, if that result is 0, because it doesn't have a remainder, it's an even number. And if it has 1, it is an odd number because the remainder is 1. So you use that a lot. And then less than, greater than, less than or equal to, greater than or equal to, equals, equals, not equals. And then you can do the same thing with doubles. This slide, any questions? Awesome. Okay, best practice, do not use, I think I'm just speed through the next like 10 because I just covered it all, but best practice, do not use equals, equals, or not equals with strings, but rather the equals method. Details later, we'll get into that. Operators for or and, use short circuit evaluation, talked about that. Best practice, be careful with the remainder operator. The second operator must be positive, and this is unfortunately not clock arithmetic, which we'll talk about later. Best practice, do not check doubles for equality. Other details later. So now we get into statements and expressions, which is another big thing that comes up. I'll be very surprised if there's not a question on it on the midterm. An expression, their definition, is a syntactically well-formed and meaningful fragment, roughly analogous to a word in a natural language, but that doesn't really mean anything to me. The better meaning or the better definition is it evaluates to something. An expression or a line of code in Java that evaluates to something is an expression. So 3 plus 4 or 8 equal 8, or hello plus world. You could look at any of these statements or expressions individually, and I could say, what is the result of that? Or what does that evaluate to? What does that expression evaluate to? And you could probably tell me, what is 3 plus 4? Cool. What is 8 equal 8? True. And then hello plus world gives you hello. Yes. So it evaluates to some value. That's an expression. So here are some examples of code fragments that are expressions. J plus 7, hello plus world, keyboard in dot next line, n equals 0, and then new simple writer 1L are all examples of expressions, because you could look at them and you could say, based on the code that you've written so far, these evaluate to some value. I will evaluate to some variable that you've most likely declared. J plus 7, an integer, a string. Keyboard in dot next line, what does that return? A string, exactly. N equals 0, return a Boolean. And then this last one, which is a little tricky, is a new simple writer, which returns an object. So what is the type of each of these expressions? The fragment creates a new object of type simple writer 1L, and its value is a reference to do that object. Details later. Who remembers the shape that we use to describe objects? No, you're good. And? Yeah. So anytime that we're reasoning about objects, reference types as we call them, it returns a reference. And this thing points somewhere. Where it points, we have a whole lecture on that. So get hyped for that. Mark your calendars. Okay. Expressions are different from statements. Statements, as opposed to expressions, is a smallest complete unit of execution, roughly analogous to a sentence in a natural language. So statements are composed of different expressions, and a statement is terminated with a semicolon, or a simple statement is terminated with a semicolon. So as opposed to, let's say, 3 plus 7, which is just an expression, you add a semicolon and you set it equal to a variable x. Now this whole thing is an expression, or sorry, is a statement, which contains this expression, 3 plus 7. There's a very good slide coming up. So here are some examples of simple statements. I equals 12, J plus equals 7, K plus plus. Oh, they didn't cover that in the slides, but plus equals is another shorthand way of simplifying your integer expressions or simplifying your integer statements. So you have an integer J equal to 4. You wanted to say J equals J plus 7. Another way that you could do that is J plus equals 7. It's like 2 fewer characters, but simpler, I guess. And then all 3 of these actually are examples of statements. So you have K plus plus, example of a statement. Simple writer file out equals new simple writer 1L foo.txt is a statement. Is a line of code in Java that is executed. File out.print hi, Mr. Fu is a statement as well. And okay, yeah, that's the same as j equals j plus 7. So they did cover it. Okay, assignment statement. The type of assignment statement is just variable equals expression. Copies the value of the expression on the right side of the assignment operator to the variable on the left side. The equals in Java code does not mean equals like in math. Recall the tracing table earlier where we talked about that. So compound statements, any sequence of 0 or more statements enclosed in parentheses is a block, which is also a statement. Here's an example. So this entire thing would also be a statement. That doesn't mean that string s equals in.next line is now not a statement. It still is, but this block of code is also a statement. The scope of variable s is just the block in which it's declared. We will talk about scope later, but essentially it's where you can and cannot use variables. There is no semicolon after a block. I don't think Java will yell at you if you put one there, but best practice is you don't need a semicolon after a block. Okay, that is statements and expressions. I think there's a very good homework that requires you to underline all of the expressions and put boxes around the statements. So that's a very good thing to look at. Yeah, question.
Just for clarity, really quickly,
Mhm.
what would the just like Reader's Digest version of statement versus expression be?
So expression, I would say if you could look at something and it evaluates to a mathematical type or it evaluates to something in Java, that you can say, you can put your finger on it and you can say that is this or that is 7. That would be an expression. And if you can look at something and you could say, like if I said int x equals 3 plus 7 semicolon, like that doesn't evaluate to something. It's
Okay.
multiple things. It's
Okay.
an assignment, it's an addition, it's a semicolon, and it's a declaration all at once.
Okay, so a statement would be like cans of soup equals 7.
Yeah.
An expression would be like cans of soup equals 2 divided by like a thing or whatever.
An expression would just be 2 divided by.
Oh, okay, I get it now.
All right, and now we're going to talk about control flow. A lot of you guys raised your hand that you had taken a Java class before, so this should be a review. We will normally use these if, else, if, else, and if, else, if. But you can use a switch statement if you would like, and then your loop or iteration statements. We will normally use while loops, but you may, if you like, use the other ones as well. For whatever reason, they love while loops in this class. For loops are just perfectly fine. If statement, you have if, test, then block. What mathematical type would test be in this case, or what mathematical type must test be? Boolean, which evaluates whether true or false. If it's true, then you go into the then block. If it's false, then you skip over it. Any Boolean expression may go here. Best practice, even a single statement here should be in a block. Don't just have if test, open bracket, close bracket. You always should put something within the if statement. Then you have your if else statement, which again takes in a Boolean. If the Boolean is true, it does the then block, else it does the else block. Best practice, even a single statement here should be in a block. If you don't have an else case, if you don't want to put anything here, then just use an if statement. And then it can be repeated into an if else if statement. Can you draw a flow chart for the statement? That is a practice that is left to the reader, if you guys want some extra practice. So while we'll continually test the test condition over and over again and continually run the while block while the test math or program variable is equal to true. Control flow here can go backwards, which creates a loop in the flow chart. So again, it will continuously run. This has implications for tracing tables, which we will get to a little bit later. So control flow for if cannot go backwards. There's no such thing as an if loop. The arrows that follow must always go forwards, as opposed to here, where you can go backwards loops. Okay, this is the slide that I was talking about earlier. This slide is very good for associating the differences between expressions and statements. And I think the homework tomorrow, it's either the homework tomorrow or the homework Thursday, is entirely on underlying expressions and then putting a box around statements. So this would be a very good resource to pinpoint if you're doing that homework. And again, we can go through each of the statements. This is a piece of Java code which is generating a simple writer output. This is a piece of Java code, which is declaring through variables. You'll notice that while loops, if loops, and well, yeah, I guess for loops as well, the entire thing would be a statement. So this is a while statement. This is an if statement. And contained within them can be other statements as well. Looking over this code right here, does anybody have any problems with what they declare as an expression or a statement? Yeah. New simple writer 1L. Yeah. So this is an expression which is declaring a reference type. So new simple writer 1L is what we call a constructor, and it's essentially telling Java, make a reference type, we're calling it output, which is pointing to a new simple writer 1L. This is simple writer 1L is still a program type, which can be modeled by a mathematical type. It's just very different than, say, an integer or a string or a character. It's an object, which is another class of variables. So anything that has that new keyword in front of it is also going to be an expression. It's just going to evaluate the simple writer 1L object. Does that make sense? Yeah. Okay. Are you sure? Okay, cool. Okay. Any other qualms? Yeah.
For the x plus plus, does the x times the underline?
Does the x not count as a statement? No, because if I said what's the value of x there, it would be different based on which run through you have in the program, which I guess could be the same said about this, but you're modifying x. So you have the value of x beforehand and you have the value of x after. You can't just point at x and say it's going to be this time. Anything else? Any other qualms? Okay, I would study this and then actually do the homework tomorrow and try, because these things come up often. And then best practices for Boolean. Here are some shorthand ways. Instead of saying b equals true, you can just say b. So this is the same as that. B equals false. You can just say not b. And instead of saying if b, return true, else return false. If b is a Boolean, you can just say return b. And if it's true, it'll return true. If it's false, it'll return false. Any final questions? And as always, there's resources if you don't like the way that I explain things.
Homework is due tomorrow before class.
I think at class, so 8 a.m. homework is
Okay.
due. Projects are an hour before.
All right.
Cool. Then you are dismissed. If you did not get the attendance code, it is there. The question is, what class are you most excited for besides mine, of course?